Welcome everyone to this edition of our Cassandra Community webinar series. I am delighted to have with us today Michael Kjellman from Barracuda Networks. Michael just gave this presentation last week at the Bay Area Cassandra Summit. Michael was up on the big stage in front of hundreds of people. So, that was a high-pressure event. I'm hoping today this will be a lot easier for you, Michael. Just kick back and relax. Just a couple of housekeeping items. So, as always, we will take questions at the end. Please use the Q&A panel inside of WebEx to ask your questions. I will read them to Michael at the end, and we'll get through as many as we can. So, without further ado, I'd like to hand it over to Michael to talk to us all about their migration from MySQL to Cassandra and things that in hindsight he wished he had known. Welcome, Michael.
Thanks, Christian. Thanks, everyone, for spending the next hour of your life with me. I am an engineer at Barracuda Networks. And sort of a little bit about what we are. We are a network security company. We make spam firewalls, web filters, backup appliances, etc. We're an appliance company, but we are moving into the cloud space. And with that, we sort of, had a big data problem. We were a MySQL house, and we are slowly sort of converting everything to Cassandra. So I am personally responsible for building our real-time spam detection and web filter classifications. I work in Java, Perl, and C, and bits of everything else, but that's sort of what I primarily work in. I am the author of Perl Casa, which is a Perl Cassandra client. Hopefully this week can finish up binary support for the native protocol for CQL. And I have been at the company for 6 years, so because of that, I sort of touch everything all over the place in the company. So a little bit about our Cassandra cluster. We have been in production for 2 years with Cassandra, and our cluster has grown significantly, and also our usage has grown. So we started around 0.8, and currently we are on 1.25. I guess it's now a little closer to 1.26. With some custom patches that we have as well. We are 24 nodes in 2 data centers, 12 in each. We use two 2-terabyte spinning disks, no RAID at all. I let Cassandra take care of the RAID. 1 small SSD we use for hot column family, 64 gigs of RAM. And then we use Puppet and Cobbler. Cobbler is a Red Hat project that lets you go from bare metal all the way through Pixboot and sort of manage that process. And Puppet is used to manage sort of config, etc. And we target load about 600 gigs, but I'll get into that a little further down. So what is real-time? This is sort of an interesting thing for us. In spam, real-time is pretty much a negative, right? You want to get it before anyone's seen it, because if the first element of a brand new campaign comes out, now that's already gotten through to someone's inbox. And just as importantly, being fast on false positives, etc. How do we get faster? And so MySQL became a huge hindrance to what our real-time behavior was going to be, and we weren't real-time enough. So here is a lovely piece of diabetes spam, and this got through, unfortunately, in our old code to about 300 inboxes. And this is what we call advertising spam. So the primary goal is to get people to go to this free diabetes thing and give them their information, etc. And our problem here is that there's quite a bit of different angles. We have like 12 to 15 different layers that we try to fight spam. So in our particular case, MySQL was causing a huge delay in how fast we could classify all of these different layers. And so sort of to summarize, before I go into the details of the rewrite, clearly Cassandra has helped us here. We have decreased our latency for our API. This number actually, I got below 1.5 milliseconds today, so that's pretty cool. The key numbers here too, we can now store 33 million objects that we track at all times in our database, versus in MySQL we could only keep about 4 million total, and we started hitting performance problems around 2 million. And obviously, the number of rows you can keep in MySQL is going to depend on your workload. Because we have a very high rate of insertions and changes, it caused the inno and MyISOM to sort of eat it a little bit. And another really important that is that because of Cassandra, we can now serve all 33 million or however many records we have to all of our customers. So with MySQL, we had we're only able to serve about 314,000. And then this one's key too. The number of times we have to see something before we actually decide, okay, hey, this may be something we want to take a look at. So when it's Cassandra, we do it on the first request. So the first time we see anything in the field that comes to us, we start investigating and having our automated classification systems go to work. In MySQL, we may have had a threshold that said 15 different units in the field would have to report that back to us, et cetera. Pretty much doing everything we could, to start to reduce the load on MySQL. We're now multi-data center. We're in 2 data centers versus 1. That's obviously a huge benefit to our customers. And then here's the real-time numbers. We went from an average of about 8 minutes of classifying a domain down to 3 seconds. And so 3 seconds actually means that we pretty much have stopped all of this particular type of spam from getting through to our customers. This article, How to Survive a Ground-Up Rewrite Without Losing Your Sanity, was tweeted by Jonathan Ellis, who's the Apache chair of Cassandra. And it was an article that we were about a month from finishing our rewrite, and I wish I had read it or that it had been written when I started my rewrite. So I highly recommend anyone who's thinking about doing this to take a look at this article. Pretty much what the summation of the article, Joel is one of the original engineers at Microsoft, and he also co-founded Stack Overflow. And so he told a tale about the current company he works at, and they had 2 rewrites going on at the same time. One was business-driven, where sales had actually been told that they couldn't sell to customers who had n number of transactions per second higher, because it was going to bring down the system for all of their previous customers. And the other one, engineering themselves, they decided, hey, this code just isn't optimal anymore. And they were a .NET Microsoft house using MS SQL. And pretty much what happened was the one that wasn't business-driven, the one that just sort of engineering said, hey, this could be a lot better, this is sloppy, that one failed because all of the features that everyone said they didn't want, well, now when they went live, those features needed to be implemented, yesterday. And then the one that succeeded, there was a real business benefit. So even if there were features missing or there were regressions, they were now able to sell to whoever they wanted to, and that's a pretty big benefit. And so I bring up rewriting, and I bring up sort of a little bit of a non-technical aspect here, because I found that when you sort of rip out a database from all of your application logic, it's going to involve a lot of rewriting. And for us, we had very MySQL-centric logic that needed to really be rethought. And I think it's significantly for the better, because in many ways, things that weren't even MySQL bound, but were because of MySQL thinking, our performance is better. And so past engineering decisions are now preventing implementation of your new business requirements. So people would come to me and say, hey, this is a particular type of spam, how do we catch it? Well, I wasn't able to do anything necessarily, or just not do 100% of the job, right? Maybe I would catch it after 300 to 400 messages had come through all of our customers, but I want to catch it on the first one. I don't want to catch it on 300 or 400. And also, increasingly, in my particular use case, we found that threats are becoming smarter and more targeted. And this is pretty important because now we can't just wait for 15 to 20 units in the field to report back to us. Every customer is just as important, and just because they have one targeted campaign and no one else does, it's not fair, that we don't give them equal priority in our cloud systems. And so, legacy systems, obviously, everyone has code that themselves that they haven't written. I would beg I've looked at my own code even just a week later and said, what the heck was I thinking? I'm sure, many people can associate with that. And you start putting all these layers of duct tape around your database. So MySQL can't scale. So then the first thing you do is you go, okay, well, master is too risky, so I'm going to put in slaves. So you put in all these read slaves. Well, now you've got slave lag all over the place. And now you've got, the bin log isn't there, and you've got to do these crazy gymnastics all over the place to get that to work. And then you've got latency between your data centers, so then slave replication just stops, and then one data center, your application isn't working, et cetera. And I'm sure anyone then who went master has had problems with IDs, et cetera, and that's just a whole, another problem. And on our MySQL system right now, we run about a minimum of 1 second slave lag, even on the weekends. Sometimes it's as high as 30 seconds. And so MySQL performance in trying to scale it just wasn't going to work. We didn't have a real good way to shard our data. And so what we would do is throw hardware at it. So we had a 16-disk RAID 60 box with 256 gigs of RAM and 16 cores, et cetera, as our master. And we tried pretty much everything. There got a point where you can't put lipstick on a pig anymore. So you can't just keep throwing hardware at the problem. You can't keep adding read slaves because you haven't fixed the underlying problem. And so you have to hit the reset button, and in our case, this was moving to a different set of tools, with the main one being Cassandra. And so our requirements were to plan for continuous failure. And I would argue that even 5 years ago, the thought of failure in your persistence tier continuously was unthinkable. So you'd throw tons of RAID cards at things, you'd throw redundant PDUs, you'd throw everything you could to make sure that your master never went down. In our case, it's a button click away for us to bring up a new Cassandra node. So you also want it to be easily scalable. You need to add nodes, you need to remove nodes. And there shouldn't be a single point of failure that you can think of. I like to put a smiley face next to that because clearly there's always the things you didn't think of that bring down the entire stack. And then also many smaller boxes versus one monolithic box. As I talked, we're using really, really cheap boxes. One of the benefits of being an appliance company is that we actually make our own cloud solutions now that we use internally. And so, our boxes are about as bare bones as possible, and I think this is a trend in the industry. And so it allows us to essentially get n number of nodes for that one that we used to have. And so back to sort of the rewrite, you have to get technical buy-in from all the parties, right? There's going to be people who aren't willing to get rid of MySQL because MySQL has done them well for many, many years. And I'm not here to bash MySQL. In fact, I think it's a great open source database, and it powers the web. It's a great database. But there comes a point in time where those people also need to understand that there's real business implications here the longer you wait. Because if you've already started to hit capacity problems on MySQL, this rewrite is going to take time. And so the longer you wait, the more you defer the problem, you kick the can down the road, the harder it's going to be to get that rewrite in on time. Before your customers really start noticing significant problems in your application. So one, I would say you should get a real big MySQL advocate in your company to sort of argue against you in a public forum and have that argument, and sort of have them talk about all the different ways that they would also, maybe on a different team, try to scale MySQL. Have you done this? Have you done that? If you don't have a good answer for what they're saying, go try to find it. And then come back to them and say, Cassandra's still the right solution. So if the business requirements, in our case, were, hey, you can't go and re-implement this for a year and come back. And so we were pretty much told within 3 months they needed certain deliverables. And it actually created a bit of an engineering problem because underlying it was, needing to set up all the Cassandra infrastructure and all of our shared common projects that other tools would use. And so it also required us to operate the systems in hybrid. So right now we have both systems running in production, and hopefully next week we will move 100% of our customers over. We're about a quarter right now in the new code and 3/4 on the old code. So this is about the time in the presentation I show you this really beautiful graph showing how great Cassandra is and how perfect everything's going to be and how you can just drop it in place and boom, everything's going to be perfect. What I should clarify here is that this was taken on a Saturday when we have very minimal email traffic, and this is what things could look like. So Cassandra is not a direct MySQL replacement, and it's not a magic bullet to solve everything. There is no tool in software engineering that is a magic bullet. And so V1 here, you can see, this was me forgetting that I had turned off a key cache on a particular column family. So I fixed that, and you can notice things stabilized quite a bit. V2, it turns out that I had not realized that there was a cross data center load balancing policy in the new DataStax driver. So I fixed that, and much to my boss's dismay, pushed the third major code change out within a few hours. And then V3 here, you can see things flattened out, and now we're down to that 2.41 average I was talking about. I don't know what happened around 8 o'clock there, so clearly there's still a few little things that could be improved. And so, migrating, it's painful, it's really painful. Have I mentioned it's painful? There's tons of rewriting, there's tons of regressions that are going to creep in, so why do it? And I would argue that Cassandra is the best option for your persistence tier at the moment. And I look down the line at other products that are being written or other trends in the industry. There's nothing really to compete right now with Cassandra. And so if you have a business reason, which I'm sure many people do, don't let your database hold you back. Don't let MySQL prevent you from implementing things correctly. Don't say, hey, yeah, we can do this and implement this half solution, because it's not going to be great and you're not going to be really proud of it. And so personally, I like to be proud of what I produce. I don't want anyone getting spam in their inbox. So the lessons we learned, the good things that we did, we really, really thought about our data model up front. And my boss and I, we joked because we had the conversation for 2 hours, just whiteboarding it over and over again, about 3 times. And then we would let a week come back and we go, wait, what did we decide to do here? And we weren't taking notes. We were just whiteboarding it. Someone would go in and erase it. And so we go do it again. And then we'd realize, hey, the last time we weren't right. And so we spent a ton of time up front doing that. And so, the old adage, measure twice, cut once, is really important. And also what we did too is all of the components that we used, as we implemented, we started realizing that what we thought we needed wasn't actually what we needed. Yet we didn't really have to change our underlying architecture. And this was really important that we figured out how modular it was. And I think going forward too, it's going to allow us to not need to necessarily rewrite the entire stack, which is pretty important. Breaking things apart versus having everything rely on one monolithic object is pretty important. And so the bad lessons we learned: consider migration and delivery requirements from the very beginning. What I thought I could naively do was to cut over 100,000 customers on the same day. And we have many, many different deliverables that we produce out of Cassandra. The thought that you can switch over all of them at once is not going to work, and you're probably going to have a pretty bad week if you do that. So how are you going to migrate customers? How are you going to not have them notice regressions? How are you going to get real live traffic onto your parallel system? All these are really important, and I don't think we really considered that because we were so worried about solving the performance problems, we didn't think about the migration problems. Adjust expectations. I didn't expect to be relying on legacy systems for so long. In fact, I stood up on stage at the summit and said that this week would be live 100%. Well, product management wanted to wait another week to get some more feedback, and so I'm still relying on those legacy systems for quite a few customers. So, the problems that you had before aren't just going to magically go away, as much as I wish they did. So, you're going to have to probably think about how are you going to keep the duct tape together for long enough. And I don't think we did that well enough. Also, syncing data is really important. So in our particular use case, we were syncing data from about 15 different sources and pulling them all into Cassandra. And what happened was I synced some data, and the epoch that we had for timestamp was 0, where it shouldn't have been. Well, naively in my sync script, I said that where the initial sync, where it was greater than 0 instead of greater than or equal. And so we missed a bunch of classifications in our sync. And what ended up happening was I blocked German, Google, Samsung.com on the day of the Galaxy 4 release, UPS.com. Luckily, I left FedEx alone for all of our customers. And it was a pretty painful day. And obviously, merging data from many different sources you're going to introduce problems. It's not an easy task. And so take your syncing of your data more seriously than your production code. Don't just write a one-off script that you think you're going to be able to run the day that you're going to do your migration and cut over everyone, because it takes time to move all that data too. So I'll get a little bit more into syncing. So here's 7 tips that I want to bring up. Start with the queries. 2, think differently regarding reads. 3, syncing and migrating data. 4, don't use Cassandra as a queue. 5, estimate capacity. 6, automate, automate, automate. And 7, some maintenance required. So 1, start with the queries. So I think there's a bit of a, stigma with, quote, NoSQL, and I sort of hate that term, NoSQL, because I think it means no thinking to some people. When you do your MySQL, table and schema, you spend a lot of time thinking about your primary foreign key relationships and how you're going to lay things out and how are you going to, reduce I/O, et cetera. Just with Cassandra, I/O and the laws of physics still play. And so you really need to think about, especially with tons of data, how are you going to lay it out? Do you want to use counters? Remember right now in the current counters implementation, it's sort of like a best guesstimate. If you, it's pretty accurate, but if you start getting tons and tons and tons of counters, you may be a few off. And then composites, how can you lay out your schema with composites, and now with CQL, obviously, that's all under the hood, to make sure that you can retrieve data efficiently. And so you need to optimize for your use case. If you're doing time series data, you're really doing writes, right? And so, how are you going to do roll-ups, et cetera? There's many articles online. And don't be afraid of writes. So Cassandra really excels at writes. You can throw millions of writes at this thing. And storage is super cheap nowadays. You can get 256 gig SSDs for like $100. And so, if you need to read some data out, write it 3 different times into 3 different column families, so then you can pull it instead of trying to think of these complex, faux joins you're going to do, in a denormalized world. And so I'll go into tombstones in the queue, but you really need to think about if you have a really high delete. SS tables in Cassandra are immutable. So once they're written and they're appended to, they don't change. And so when a delete happens, a tombstone as a little flag is appended to the end saying, hey, look, everyone in this distributed system, this is not valid anymore, it's deleted. So that data doesn't just magically go away until you do a compaction. And so if you don't remove that data in the compaction, it still has to go through and iterate through all of that. And so you really need to think about tombstones, counters, composites, and how you're going to lay out. 2, think differently regarding reads. I think because MySQL performance is so horrible, we tend to think like, I need to get all my data at once and pre-populate my cache. So I'm going to try to pull out all 4 million records and, load this crazy, table and create a, Tokyo cabinet file, et cetera, from it. Who knows? With Cassandra and that's probably the wrong approach. So instead, how are you going to do it? And so there are cases where you do need to iterate over every row and do a read. So in these cases, we use Hadoop and Pig. There's plugins just natively in Cassandra that will work with Hadoop. There's examples if you just get the source or binary distributions from the Apache Cassandra website. And then in our case, we had a use case where we needed real-time ordered results on about 15 different columns at all times instantly in real time. So times, like when did this last element hit across 32 million rows. And so that served to be pretty difficult because in a distributed world, now you need to go get reads from all these different nodes and munge them together. And so doing ordered results is really hard. So we use Elasticsearch here for that one particular use case. Syncing, back to that, really take it more seriously than production code. And so design your sync to be continuous. So we sync all the time. And a mistake that I naively made too was, oh, hey, I can just iterate from the last time I synced to the current time and move all of it. Well, what I forgot is that there's some data that really, really needs to get to the new code faster. There's some that is sort of important, and then there's the stuff that I really don't care if it gets there within 24 hours. And so you really need to think, how can I split up my my sync into different buckets, et cetera. That's probably one of my biggest mistakes, was not thinking about priority and not taking the sync code super seriously and doing regression testing, et cetera. 4, don't use Cassandra as a queue. So previous development in our system actually is using MySQL in some ways as a queue. And so we have a single thing that goes and pulls a particular table and sees, hey, are there any changes? And it grabs all of them and then it deletes all of them. That was probably not the best solution then, and Cassandra is just as bad as that, even though it's really tempting. So here's a great blog article you can read on the technical reasons why you shouldn't use Cassandra as a queue. It goes back to tombstones. And so instead, we use Kafka, which came out of LinkedIn. It's now an Apache project. It's awesome. 0.8 is a really, really great release. Multi-publisher, multi-consumer, and it's written to disk too. So if things go down, it can replay transactions. So that's pretty awesome. And so us using Cassandra with Kafka and letting Cassandra be good at what it's good at and Kafka do what it's good at has been a match made in heaven. And our performance is just incredible. So 5, estimate capacity. So don't forget that Cassandra is a Java app. So before this, I wasn't really a Java developer. I had taken object-oriented classes in school, et cetera, and played around with Java. But I hadn't really deployed it to a huge load. And so the Java heap, you really don't want to use, at least with the Hotspot Oracle JVM, any more than 8 gigs because you'll start dealing with garbage collection. And so GC pause, essentially the stop the world garbage collection, where the whole JVM just pauses everything trying to get rid of and walk the whole stack. And so you can't, even if you have 64 gigs of RAM, you can't just go throw 64 gigs on the Java heap. And so you need to plan your capacity in mind of this. So what I recommend is get a piece of hardware you're happy with, use the stress tool, which comes with Cassandra, benchmark that one node, and then figure out with your replication factor, how many of these nodes do you need and how many data centers, and then do that. I/O is still a concern, so just because it's Cassandra and just because it's new and just because it's awesome doesn't mean that I/O isn't a problem. If you have a 7200 RPM disk, you're going to have just as many problems. And so that sort of brings me to MySQL hardware is not Cassandra hardware, right? So using lots of cheap disks and lots of cheap boxes to replace one giant expensive box is definitely the way to go. Because if you're going to assume in your design that you're going to be continuously failing, if you have 1 or 2 or 3 boxes and you load them up to 1.2 terabytes worth of data per node, it's going to really hurt when you lose that node, right? But if you lose one and you only have 200 to 600 gigs on it, and it's easy to bring it up, you don't need to copy 1.2. Copying 1.2 terabytes of data, it's pretty hard. It's rough. So keep that in mind. Don't forget what you've known for your entire life in terms of I/O. And so love your inner op self. So distributed systems, they move complexity to operations. And so a little story, I was on the IRC Cassandra channel, and a guy around New Year's had decided to upgrade his 30-something node cluster. And he decided to do it all manually. And what had happened was 2 or 3 of his 30-something nodes had come up in the test cluster. And the only way that that should probably happen is if it was the stock config. And pretty much what had happened was he had used the upgrade process and had forgot to replace it with his actual config for his node. And he was arguing to me that he purposefully didn't automate because he felt that automation was going to cause problems. This is the wrong solution to think of. Automate and test in your dev production and then stage it. Because what you've done is by adding all of these layers of nodes, et cetera, you've added a ton of complexity to your applications. And so if you don't really think about how are you going to, automate this and add a node, right? When a node dies, if it's not super easy to bring it back, you've just created more problems for yourself. So we use Puppet. You can use Chef if you want. I'd recommend still against Puppet or for Puppet. You could create a tarball and rsync it around and have it expand, whatever works for you. But automation is really important when you start talking about distributed systems. And so there's also a code written by Sylvian from the Cassandra team called CCM. And what it allows you to do is create a local dev cluster on your MacBook Pro or whatever. And so the cool thing here is my coworker, we actually wrote a script. It creates a brand new CCM cluster. It populates the schema. It goes to our production cluster and grabs live data that just hit and then populates it into your dev cluster. And so the cool thing is here, it's literally one run of the command line. We can all get our own dev nodes with real live data. Obviously, you don't have the load on it, but you can use Stress Tool for that. And then you can operate Hadoop on it. You can operate everything. You can test your new code, and it's really nice. So I'd recommend learning CCM at the beginning rather than later. 7, some maintenance required. So as I mentioned, it is a Java app. And so you need to learn some of the Java tools that are in the JDK. They're really not that hard. I know that there's a little bit of this, oh man, there's all this stuff I don't know. Believe me, I was there, and I think everyone's been there. So JConsole is really cool. It will let you see all the different MBeams management ways you can touch Cassandra internally while it's running, and you can also see performance of the JVM, et cetera. And so you can look at JConsole. It's just in the bin folder of the JDK you download on the Oracle site. There's also JStack if you have problems, et cetera. So, you don't need to become a Java expert, and I don't want to convey that, but getting a little bit of an underlying understanding about how do I monitor it, because as a Linux person, the inclination may be, oh, I'm just going to strace the PID and take a look at what's going on. Where's my I/O? What's the problem? If you strace the JVM, you're just going to see a bunch of futexes, and it's useless. So you really need to get inside Java to understand what's going on, and you need to do that. Repairs are sort of a pain point, I think, for many in Cassandra. If you do them constantly, you're going to be better off. So what we do is the equivalent of a rolling restart. We do a rolling repair. So we try to have one node either doing a repair or cleanup at all times. So it spreads the load out, and if we do it frequently enough, less ranges are out of sync, meaning less data needs to be streamed, which means less I/O. And then one thing that we also use is Joomla, which exposes JMX, which is the Java management over HTTP. So we just use Perl, but you can use anything you want to automate this stuff. So, rolling restarts, upgrades, what are our performance metrics, et cetera. We pull all of that out. That's free. You can hook that straight in. And then to summarize where Barracuda is today, so we've been in production for 2 years. We store a variety of data of sizes in Cassandra, and it was the right choice. And after 2 years, I lost a little hair sometimes, but I still love Cassandra. Frequently I've noticed 2 other teams within our company, they're coming to the decision to use Cassandra, not even with talking to me. They'll be like, oh, you use it too, and I talk to them, and so, it's really awesome. So we've got two product lines, 100% on Cassandra, and then Spam Firewall, which is our biggest. Next week we have a firm date. We're switching everyone off. And we achieved the real-time response. So the most important thing here is that our product management teams, our sales teams, they're excited to go now sell spam because we don't have to really hide behind metrics anymore. We're really proud of our numbers. Classifying something in 1 to 2 seconds is pretty awesome. And our accuracy and false positive rate is really good as well. And so 2.0, there's a little bit of a transition right now in Cassandra from Thrift to CQL. Thrift will continue to work, and in fact, in 2.0, it's now 2 times faster than it was before, which is really cool. Pavel just committed that. So what I would argue, though, is if you're coming from the MySQL world to Cassandra, CQL is super cool because it allows you to do everything without needing to understand what a slice predicate and a get multi-slice array, et cetera, all these thrift terms. It's just not friendly. And so we have some older engineers who may not be as excited to learn newer technologies, but they want the power of Cassandra. And so everyone understands select star from foo. And so I really like the fact that, if there's people who are thinking about the data model, et cetera, and how to, properly use Cassandra in their use case, you've now made it really accessible to everyone to also get at that data as well. And Cass is a pretty cool way if you really need, more transactional stuff. It makes it even better, drop in MySQL replacement. That's also coming in 2.0. And so finally, just to wrap it up, the Cassandra community is freaking awesome. So, there's other solutions. You should definitely go out and do your homework. So there's React, which is Erlang based, HBase, which is really just a key value pair solution, but it scales well. I would argue Cassandra scales just as well. And then if you want to spend millions of dollars, you can go with Oracle. But why would you when you have a great solution that scales, that has an awesome community, where there's great commercial options, and most importantly, the people who were working on this project, they love this thing. It's their life, and so their goal is to make this thing work for you and for your project. So IRC is there for you. I didn't really use IRC beforehand. So don't be that afraid of it. Just Google Freenode, and you'll get the URL. You can connect to hashtag Cassandra. And there's people there who just want to help you when you hit a snag, when you don't know what to do. And there's also the mailing list, user@CassandraApache.org, which has tons of data. It was going directly into my inbox for about 4 months, but then the load got a little high, so I had to filter it. But there's tons of information in there. And once again, there's tons of people who just want to help. And so with that, thanks for listening, and time for questions.
Much indeed, Michael. A great talk and chock full of good information. We have got some questions for you, Michael, but we'll continue to take them. So if you have a question for Michael, please type it into the WebEx Q&A panel. While we're waiting for those questions to come in, you can see any previous webinars that we've done at the link that we're displaying there. They're also all available on Planet Cassandra. And then also, if you're interested in learning more about Cassandra and would like to take training, these are our upcoming training dates with the URL there as well. So Michael, fasten your seatbelt. Are you ready?
Ready.
Okay, so you did mention there a little bit at the end some other solutions. With HBase itself, did you get a chance to evaluate that? And if so, what was your takeaway?
So I think if you're storing stuff like a lot of binary blobs, et cetera, if you are Facebook and you're just storing terabytes and petabytes of pictures, then maybe there's a good use case for you. What I would say, though, is that most of the people who are looking for a replacement for MySQL will not be happy with HBase. So, any good engineer is going to go do their homework, and, clearly there's a lot of good use cases for HBase. But, especially with CQL now, I think that Cassandra is a significantly better option than HBase. And performance numbers as well, too. You'll see that Cassandra actually in most benchmarks significantly outperforms as you increase the size of your cluster HBase.
Great. And next question, can you explain why you recommend this one from Blaine Hilton? Can you explain why you recommend Puppet versus Chef? I was thinking that since AWS seems to be supporting Chef, that may be a better choice.
So internally, we've used Puppet now for 3 or 4 years, and I think the project has matured. Personally, I just don't like Chef, and to be fair, too, I don't like Ruby. So I'm not advocating Puppet because it's in Ruby. I'm just advocating because I think it's the best option. I think there's much more support for Puppet. I've also heard of many horror stories in production with Chef. I've heard pretty much no horror stories with Puppet. And so I guess I haven't personally run Chef in production, but I have friends who have run Chef in production, and they're now all using Puppet. So, but there's great built-in tools in AWS for Chef that definitely do that. The key that I would stress is that, make sure when you pick your automation framework, it should work for you. It shouldn't work against you. So if you're constantly fighting it, it's going to make things worse. And I think then you decide, oh, well, I'm not going to automate anything anymore because I hit that. And so, whatever works best for you, I think is the best solution. But right now, I think Puppet is the best option.
Okay, great. And this one from Aaron Dorfman. You mentioned Cass and other 2.0 features. By the way, I'll take this one, Michael. So what is the release timeline for 2.0? And when does DSE, that's DataStax Enterprise, plan a 2.0 based release? So my understanding is that 2.0 will be available sometime in July. So let's say before the end of July, it will go to a vote and then get released. And I know from a DataStax Enterprise perspective, we are aiming to have 2.0 in DataStax Enterprise in our October release time. So Michael, Aaron has a follow-up question that I'd like you just to talk about, which is, can you mention the specifics on achieving real-time search against Cassandra using Elasticsearch?
Sure. So it's a little bit of a hack job. I'll be 100% honest. We have a Kafka queue where essentially anytime there's any modification on an element, we queue it, and then we have a process that goes through, dedupes those requests within a 1 or 2 second period, and then repopulates them in bulk every 30 seconds back into Elasticsearch. So there's a maximum of about a 30-second lag in our Elasticsearch index. Triggers are coming in 2.0, and they're pretty flexible. So what I will play around with, and I'm a little concerned about performance of putting a trigger for every single update. Obviously, it's probably going to just kill our performance. It won't be a real option. But you may be able to hook in a trigger and then update Elasticsearch there. So there's some APIs where people, tried to hook in and build custom class loaders to populate Elasticsearch. I think in practice, though, even though it's quote a hack job, it's not really hacky. 99% of our data is in sync, and I have a sanity script I run, to make sure that everything's in sync after that. So it's not perfect, but it's pretty good. And our main use case is to get those sorted orders. So we still rely on Cassandra as our actual answer when we render the actual element.
Okay, great. And Dimitri asks, how do you use CQL in Perl for Cassandra?
So Perl Casa has CQL support and that works over Swift currently. And as I said, hopefully, fingers crossed, I'll get some time to finish up the native protocol. So you can just do execute statements in Perl like you normally would with the Python driver, et cetera. And then you get back a result set and you can iterate over them.
Okay, great. Tamas asks, could Redis have been considered as an alternative when migrating from MySQL? Tamas, I don't know too much about Redis, but we have on Planet Cassandra a 5-minute interview with Instagram that we did recently where they talk about migrating from Redis to Cassandra. But Michael, just interested if you have any perspective there.
Yeah, I was actually gonna bring up the Instagram use case as well. Oh my gosh, what is his name? I'm blanking on his name.
Rick Brent.
Rick, thank you. Yeah. So Rick's an awesome guy, and we have an intern actually working on a project with Redis, and he almost brought down one of our infrastructures with it. Inherently, I understand the problem that they're trying to solve with Redis, but there's a reason that memcache is awesome, right? I mean, it is just a key value in memory cache. And this hybrid solution that Redis has got going with trying to now dedupe and replicate this stuff, treat your cache as a cache and treat your persistence layer as a persistence layer. This hybrid solution of trying to keep this stuff is just not great. In Cassandra, you've got a cache that you can use. If that's not enough for you, if you've got some really, really heavily cacheable items, throw memcache in front of it as well. I'm not bashing Redis, but I've yet to see someone, really come out there and say, hey, look, this thing is freaking awesome. In fact, people seem to be migrating away from it.
Okay, thank you. Ashok asks, what is the replication factor you're using, and how many nodes do you have?
Sure. As I mentioned at the very beginning of the talk, we have 24 nodes right now. And we have 12 in each data center, 2 data centers. For all of our important data, we use a replication factor of 3. And we have some binary objects that we use that we store in Cassandra. And for those, we use a replication factor of 2. That data also, too, if we lose it, wouldn't be the end of the world. So I don't really mind having a replication factor of 2. But also storage consideration, there's just no reason to keep 3 copies of it around. So. Okay,
great. Jinjan asks, is using Cassandra to store terabytes of raw data a better idea than local file system?
Yes. So we had, as I said, 15 different sources.
So, yes.
We had 15 different sources, and there was this love and affinity for, putting stuff in these flat files. And what happens is if you've got flat files all over the place on these boxes that aren't backed up with critical business data, I mean stuff that makes your company money, is now on these non-backed up flat files. So also, too, from a performance standpoint, you really need to be loading this multi-meg file in and out of memory and trying to parse it with new lines, et cetera. That's the old MySQL thinking, is doing that stuff. The biggest challenge, other than getting away from MySQL, is getting my company to get off of the flat file mentality. Put it somewhere where it's going to be backed up, it's going to be, compressed, it's going to be stored, it's going to be replicated, it's going to be managed by an operations team. There is zero reason why you got to keep all these flat files around anymore. Great question.
Great. We are blowing through questions aplenty, and there are plenty more coming in. So take a drink of water. Let's keep going. David Webb asks, how did you configure your disks in each Cassandra node? Did you use separate disks for commit, log, and data, RAID, or did you just keep it simple?
Sure, yeah. So we use the SSD to pin. So in 1.1 and above, you can actually symlink, or you can pin column families. If you look at the structure of the data directory, you can pin a particular column family's folder to the SSD. And so that may be a use case for very read-sensitive latency. You could move just one over. We also have a separate disk for commit log, et cetera, and then we use the other disk for storing the data directory as well. But yeah, we do keep those separate.
Okay, great. And Vladislav asks, how big is the team that was involved in making and running the rewrite, including devs, testers, and OPs? And we get this question quite a lot, Michael, about sizes of teams needed to operate Cassandra.
So I did personally most of the rewrite myself. My colleague Sheetal, was really, really important, but she actually was hired on. It had never used Cassandra when we hired her on, so there's a bit of a ramp-up period. But I'd say, we wouldn't have got here without the help. So primary, and then my other colleague, Colin, he really helped. He wrote all the CQL support into Perl-Casa, which we really wanted so we could standardize around CQL and all of our application logic. So I had to have him. And we have one ops guy. So I also do a bunch of ops. So I'd say core people, it's about 4, with most of the logic being implemented by 2. And we now have about 12 people who are going to be working on application logic that will be based on Cassandra data.
Okay, great. And that dovetails nicely with a question we had. I'm trying to find it. I forget who asked it, but it was basically around, hey, no offense, but would a team of dedicated MySQL DBAs have been able to optimize MySQL better?
No offense taken at all. And in fact, as I said, get a MySQL advocate in the room with you and fight for MySQL. So we did this, and we actually did it 3 times, where we had 15 of some of our best engineering minds who love MySQL. And we have a lot of business logic running on MySQL. And as I said, I'm not bashing MySQL. But we reached a point with our amount of data that MySQL wasn't going to scale. I mean, you could take a look at Facebook. Facebook has gotten MySQL to scale. There's no question about it. But I also talked to someone at Facebook, and they have 6 layers of caches sometimes in between, when you click something and when it gets to MySQL. I've logged into Facebook before, and it says, due to your particular database being under maintenance, you won't be able to log into Facebook. I don't personally think in this day and age you should be able to say, hey, we're going to take that database offline and you just can't log in. Even if it's affecting 0.0001% of your millions of users, it's still kind of a bummer, and you can't get on when you want to use it. I think obviously there's ways you can scale it, but we reached the point where MySQL was no longer the solution for us. If you have not reached the point where MySQL is the solution for you, you probably don't have a business reason to do the rewrite, and you probably shouldn't do it because you're going to introduce regressions, and it will take your focus away from the real application logic you should be writing. But in our case, we couldn't scale MySQL anymore, even with all the internal knowledge of MySQL.
Thank you. And Alex asks, what tools do you use for syncing the data between Cassandra and MySQL?
It's all proprietary. It's written in Perl and Perl-Casa, just because I like Perl. That's about it. There's just a bunch of application logic that we have with how to munch the data from MySQL back and forth, and to check the check the consistency after, et cetera.
And did you write that stuff yourself because you couldn't find any good tools out there? Are you aware of any sort of open source tools people could use?
Not aware of any open source off-the-shelf stuff. I didn't even think about going to look for something off the shelf. I think with syncing data specifically, it's so specific to your data, it would be pretty hard to get something off the shelf.
Yeah, perfect. David asks, which client library do you use? Hector, Astyonix, or something else?
So on the Perl side, we use Perl Casa, and on the Java side, we are using the DataStax Java driver, which is awesome. So we are pretty much very soon, hopefully end of month, will be 100% on the native protocol that was introduced in 1.2. And so after Astyonix is a great client from Netflix. It's really awesome. But we are personally, or as a company, we're moving on from Thrift. So if you still have legacy code, I would, and have used Astyonix. I didn't really like Hector, to be honest.
Okay, great. That's still coming. We've got 4 minutes left, so maybe keep the answers a little shorter where possible. Leica asks, if you're allowed to share this information, what is the largest volume of data that you've supported?
In terms of transactions per second?
Petabytes? No, just size, size of data.
We're currently, so we're about 6 terabytes right now of data stored in Cassandra. Our numbers there with the 33 million are a little low because of the fact that we couldn't keep stuff in MySQL. We were actually going in and deleting data that we didn't think was pertinent anymore. And so I expect our data to balloon now that we don't have to artificially delete data. The current number is 6 terabytes.
Okay, great. Jairam asks, well, that's a DataStax Enterprise, so I know the answer is no to this one. Using Hadoop over Cassandra solution from DataStax Enterprise, I don't believe you've looked at that, but do you have Hadoop in your environment?
Sure, yeah. We use Hadoop and Pig.
Okay, great. So you mentioned having .NET. This is a great question because we're seeing a lot more .NET developers coming to Cassandra. So Rich asks, you mentioned having some .NET developers on staff. Are they accessing Cassandra? And if so, how do they do that?
We don't have .NET. That was actually in reference to the blog article I was referring to that Joel was working at. He was at a .NET house. So I have no experience with .NET in production, and I'm sorry if I conveyed that incorrectly in the talk.
Oh, so Rich, we are starting to see more .NET developers coming. Microsoft has Cassandra running in Azure, so that's really helping the adoption there. And we have a driver in beta, a .NET driver that will be GA very soon. So trying to make it a lot easier for .NET developers to work with. Okay, and then Michael, would you recommend, maybe you talk about how you do this, but would you recommend using Cassandra for a high availability OLTP application? It's sort of Cassandra's sweet spot.
Yeah, I think the key here is you need to make sure that your ops are going to be ready for it. So if you get a 3-node cluster and you lose 1 node and you have a replication factor of 3, you will have transactions failing. So yeah, it's what Cassandra is built for and what it's great for, but as I said, it's not a magic bullet, right? If you don't understand what the replication factor is and you also haven't tested how you're going to deal with node failure, your outages may be worse than they were before.
Okay,
so,
great.
just make sure you plan that and think about it.
Last question from Gus. You mentioned you optimized the cache for CF keys. Could you elaborate on that, please? And if there's any pointers of places to go for education, that would be appreciated too.
Sure. So I don't have like a link offhand right now, but there's a row cache and there's a key cache in Cassandra. And in 1.2, they're both off heap, and they were moved. It used to be JNA, but now to Java MISC unsafe. So the benefit here is that you're not limited by the Java heap when you're using your cache. So you can set that and optimize. So by default, it's keys only, I believe. You can also set it to rows only, all, or none. And so in 1.2.0, there was a bug with caching, so I had turned it off, or I thought there was a caching bug, and so to test it, and I just forgot to turn it back on.
Okay, so that brings us to the end. We're exactly at the top of the hour. Michael, thank you so much. This webinar will be available as a recording, as will Michael's talk from the Cassandra Summit last week. We received those videos, we're uploading them, and we anticipate, maybe Tuesday or Wednesday next week, having those available. So, Michael, thank you so much. We really appreciate it. Some really good questions here at the end as well.
Thank you.
Okay, thanks.
All right, take care. Bye-bye.